Good morning, class. We are looking at practice test number 5, module 5, covering chapters 10, 11, and 12. Here's chapter 12, analysis of variance. Chapter 12, analysis of variance, or in short, ANOVA. That's what we are going to look at, analysis of variance. One-way analysis of variance, also known as ANOVA, is used for test of hypothesis that 3 or more populations have means that are all equal, as in H0, mu sub 1 equals mu sub 2 equals mu sub 3 by analyzing sample variances. One-way analysis of variance is used with data categorized with one factor or treatment, or there is one characteristic used to separate the sample data into the different categories. The populations have the same variance or standard deviation. In the F test for analysis of variance, ANOVA, two different estimates of the population variance are made. The first estimate is called the between group variance, and it involves finding the variance of the means. The second estimate, the within group variance, is made by comparing the variances using all the data, and is not affected by differences in the means. If there is no difference in the means, the between group variances will be approximately equal to the within group variance, and the F test value will be close to 1. Do not reject the null hypothesis. If the mean differ significantly, the between group variances will be much larger than the within group variance. The F test will be significantly greater than 1, therefore reject the null hypothesis. Remember, we make F a right tail test, which is S1 squared over S2 squared in the F test. The ANOVA test is right tailed because only large values of the test statistic cause us to reject equality of the population means. Other statistical tests, Shapey test and Tukey test, are used to find where the difference exists, although the t-test is commonly used to compare two means. It should not be used to compare 3 or more. So let's take a look at this example. Weights in kilograms of cypress trees were obtained from trees planted in a sandy and dry area. They were given different treatments as indicated. Fill up the table below and use a 0.05 significance level to test the claim that the 4 treatment categories or factors yield cypress trees with the same mean weight. So no treatment, that's one category. Using fertilizer, the second one, irrigation, the third one, fertilizer, and irrigation is the last category. So what we need to know, let's look at the count. And of course, 1, 2, 3, 4, 5. Each one is 5. We are going to sum them up. That means we're going to add this, we're going to add, okay. Average, add them up and divide by 5. The same thing, add them up, divide by 5, because n happen to be the same. And the variance is s squared, which is summation of x minus x bar quantity squared over n minus 1. And so this is calculated using a calculator, of course. But we know all those formulas. So this would be the mean for this. This would be the variance for this group. This would be the mean for this group, so on and so on. To fill this up, source of variation, where the variation comes from. First, We calculate the grand mean, meaning from 0.25, 1 point, add all of this from here to here and divide by how many? 4 times 5, 20. That's called the grand mean. So how do we find the grand mean? All of these values, add them up, divide by total size. Done. SS stands for the sum of squares in between. So sum of square between is n sub I times x sub I bar times minus x sub the grand mean. So in this case, for example, 1 point, okay, this one means 1.19 minus 1.0935, and n sub I happen to be 5 for each case. Okay, so 5 times the difference between the two squared. And for this one, 5 times the difference between x2 bar, this one and this one squared, plus 5 times this one and this one, the difference between these two squared, and 5, the difference between these two squared. So that's the meaning of that. And we end up with this number. So we write it here. That's called SSP. We're going to fill up this table. I want to show you how to fill up the table. Now, it's important to know the total is 20. So each one, okay, each one has 5 minus 1, 5 minus 1, 5 minus 1. That's why n minus k, that's really refer to the degrees of freedom for them. And k minus 1, 1, 2, 3, 4 categories. You have 4 categories. So k minus 1 is 3. And in between, you divide by its degrees of freedom. So these are the degrees of freedom. This is for in between treatments, within, and this is the total. The total is simply capital N, if you will, total N, which is 20 minus 1. So now all we have to do, divide this one by 3 to get this one. This is the mean square now. This is the sum of squares. To find the mean of that, you have to divide by the degrees of freedom, which is k minus 1. And k minus 1 is 3. And so this number goes here, okay? So when you have this number divided by this number, you get this number. That's all. SSW or SS within. N sub I minus 1 times S sub I squared. So the variance for this group is this one times N minus 1. For this one is this one times N. N happened to be 5 for all of them. That's why we have 4, 4, 4. So this number, okay, times 4, this number times 4, this number times 4, this number times 5 minus 1 or 4, add them up. That is, by definition, the sum of squares within. Now, you put it here. Now we're going to divide by this number to get this number. So, by the way, what is sum of total? If you add these two, SST means the total. So sum of total is this number. And it's the sum of those two. Sum of squares. By the way, as far as calculation of sum of total, besides that, you can say this one minus the grand total quantity squared plus this one minus the grand total quantity squared all the way to the last one. That's another way of doing the calculation. Now, what is the mean square for the within, you divide by n minus k, or 16 that you put here. And you get this number. A second method is just add up these numbers, add this last column, the variances, and take a mean of that. How do you take a mean of those numbers? Divide by however many, divide by 4. This number is the same as this number. Okay, this is the mean square within, and you put it here. Finally, how do you calculate f here? Is the ratio of these two numbers, ratio of these two numbers. You get 0.3897. You put it here, and that's it. Now, we're going to go to the next page, and we're going to write the information from the previous page. Now we are ready to write the steps. Number one, H0, mu1 equals mu2 equals mu3 equals mu4, because we have 1, 2, 3, 4 categories. And that's the claim. Number H1, at least one of them is different, and it's a right tail test. Remember that it's different than previous stuff. We take it to be right tail test. The next step is to find the test statistic. We've already done that. Here's the test statistic. The next one is to find the critical value. Again, we've already done that, but the methodology is this. There are 4 categories, so degrees of freedom of a numerator is 3, 4 minus 1. Total sample size was 20 minus the number of categories 16, so degrees of freedom of the denominator is 16. And if you look this up from the table, you get to the same answer. So this one from the table or from the calculation we did before, or from technology makes no difference. You remember how we did the calculation here, right? How we came up with the calculation here, right? It's the ratio of these two, and those are the degrees of freedom of the numerator and denominator. If we look at the graph, here's the critical value of 3.2389. Here's the test statistic, which is way into the non-rejection region. So don't reject or fail to reject H0. And by the way, the p-value is way larger than alpha of 0.05. That results in the same thing. So whether you look at the p-value and compare it to alpha, or look at this. So the p-value is way larger than alpha. So compare the two numbers, or compare the two areas, and you come up with the same result. Fail to reject H0. If claim is true, there is sufficient evidence to support the claim that 4 population means are all the same, because we are not rejecting H0, so they become identical. We conclude that the 4 treatments do result in cypress trees with the same weight, so it makes no difference. Given the readability scores summarized in the following table, and a significance level of alpha equals 0.05, use technology to test the claim that the three samples come from populations with means that are not all the same. So these are readings from Clancy, Rowling, and Tolstoy. So we have to calculate n, x bar, and s. So for each one, and we put it into technology, it gives us that one. I want to show you the Excel result, and then I'm going to discuss TI as well. So first and foremost, H0 mu1 equals mu2 equals mu3 because we have only three groups. That at least one mean is different. That makes it right tail test. And if you look at this one, we are testing the claim that becomes the claim. This is test statistic 9.469, 9.46949. Critical value is given or comes from the choice of alpha with degrees of freedom of the numerator is 3 minus 1 or 2. Denominator is 36 minus 3 or 33. Alpha is 0.05. This is from the table or table of F test, or just it's been calculated for us. And so if you look at this clearly, test statistic, which is 9.4695, is way larger than the critical value. If you look at the p-value is also less than alpha, they result in the same thing, which means reject H0. So this is way smaller than alpha 0.05. So rejection region here, reject here, the same result, reject H0. So when you reject H0, that means you accept H1, the claim becomes true. And therefore you rewrite as follows. There is sufficient evidence to support the claim that the three population means are not all the same. We conclude that those books have readability levels that are not all the same. Now, what about technology as far as TI is concerned? So you clear list L1, L2, L3, and in L1, you put the information from Clancy. In L2, you put Rowling, and in L3, you put Tolstoy. So you have three lists. Then you go to the test, ANOVA, and all you have to do, put those L1, comma, L2, comma, L3, close the parentheses, and it does the one-way ANOVA, and it gives you some information. So take a look at this information and compare and contrast to what we have from Excel. Let's see what is given. This gives you what? The test statistic for the F value, and this gives you the P value. Please understand this is 5.621 times 10 to the power of -4. Okay. This one is what the Excel gave us. Okay. The sum of square between degrees of freedom and the mean square. Degrees of freedom is 2, sum of squares and the mean square. This one, sum of the squares within degrees of freedom, the mean square from the Excel, and this is the information. Degrees of freedom is 33, sum of squares, the mean square from the TI.